All right, guys, in this video, we're going to talk more about special right triangles, but we are going to talk about the 45, 45, 90 set of special right triangles. So hopefully we watched the 30, 60, 90 first. Now we're going to talk about the 45, 45, 90s. So before we even look at a triangle, we were wondering or trying to remember some things that we know about squares. And something that I remember about a square is that all the sides are equal. And all the angles are equal, and specifically equal to 90, which that's important because then when I draw in a diagonal, so a diagonal happens when I connect corner to corner. What I end up with are two right triangles again, and both of these right triangles are congruent to each other. So if we just take a look at one of them at a time, if I have, I should say too, I'm getting ahead of myself. Not only when I draw that diagonal in do I get these two congruent triangles, but it also divides the 90 into two congruent halves. So these two sides are like the two sides of the angles were cut in half or bisected. So that's how we get the 45 degrees and 45 degrees. Also, like when we're looking at it now, I do have an isosceles triangle, and in an isosceles triangle, if two sides are the same, then the two angles are the same that are at the ends of them. So that being said, if I am looking at an isosceles right triangle or a 45, 45, 90 right triangle, if I know one side, I can know all the sides, which makes this kind of better than the Pythagorean theorem, because with the Pythagorean theorem, I need to know two sides to know the final side. With this, I only need to know one. Because if I know one side of the isosceles triangle, like one of the legs, let's say that that's x units long, then the other one would be the same amount. And so if I wanted to find the length of the diagonal, or D, or the hypotenuse of the right triangle, I can do that because I'll know two things, and then I can find the third. Now it's going to look a little weird when we do it all with letters, but this is just how the pattern always works out, or how our little shortcut always works out. So we would do leg squared plus leg squared equals hypotenuse squared, or diagonal squared in this case. Now, if I'm trying to solve for D, we're like almost there, but on this side, I do want to combine these, and I can because they're like terms. So if I have 1x squared plus another 1x squared, I have 2x squareds. And then to get D all by itself, I would just square root both sides to cancel that out. And then over here, I have to square root each thing. And like the square root of 2, I do not know. But the square root of x squared is just x. So like that can come out. And so we end up with this side always being x root 2 units long, which is super nice because, again, if I know one side, I can know all the sides. So if we just try a whole bunch of this pattern here, these are my two congruent sides, so my two legs. So like leg, hypotenuse is always root 2 times as much. So if I know that one leg is 3, the other leg is 3, the hypotenuse is 3 root 2. If I know that the hypotenuse is 7 root 2, then both the legs are 7. Super easy. Like you just put a root 2 on, take a root 2 off. Although, like we talked about last time, that's not really a mathy thing. Like putting a root 2 on and taking a root 2 off is not super mathy. So like if that root 2 is not in the right spot, like if I know that this side here is 10, like that's where the root 2 is supposed to be, and it's not. So like when I go from here to here, I still got to take the root 2 off, which really means I'm dividing by root 2. And again, like we talked about in the 30, 60, 90 video, I can't divide the 2 and 10 because one is inside a root, one's outside the root. I also cannot leave a root in the denominator. You need to multiply by that same root on top and bottom so that I'm only multiplying by 1. And so I'll have 10 root 2 over, now root 2 times root 2 is root 4, which is 2. But now this 2 is outside, so I can divide the 10 and 2 for 5 root 2. And so this leg would be 5 root 2, and so would the other one. So kind of like with the last one, with the 30, 60, 90, there is a little bit of a pattern here when I go from no root to root. Like, and the root's supposed to be on the hypotenuse. So another example of that could be, like if I had 28, I can know very quickly that this is like where the root 2 is supposed to be, but since it's not, these will both have to have a root 2. And then I just divide that guy by 2, so 14. Or I just think 2 times what is 28. Now the same is true if they tell you that the leg of your isosceles right triangle is like 9 root 2. Well, the other one's 9 root 2. And then your hypotenuse would be 18, because we just times them together. Because we're really times them by root 2, and root 2 times root 2 is root 4, which is 2. Smushed against a 9 is 18. I'm trying to think. Oh, yeah. Here's another good one. So 15. It's supposed to be like 15 root 2, but since the root 2 is not there, I got to have root 2's on these guys. And normally we think 2 times what is 15? And not so much. Or the other way to think about it, right, is to take half of this and put it right there. And half of 15 looks like just half of 15. And so I'd leave it as 15 over 2 root 2. So again, it's just a pattern. It's over and over and over again. If this guy is 7, this guy is 7, 7 root 2. Oh my God, I already did that one. I don't know why I'm obsessed with 7 right now. If this guy's 11, 11, 11 root 2. If this is 19 root 2, then this is 19 and this is 19. If this is 100, then this is 50 root 2, 50 root 2. If the hypotenuse is root 2, then there's kind of a hidden 1 in front of that, so these would both be 1. So 1, 1, 1 root 2. All right, so if we take a look over here, we have our pattern at the top. Taking a look at this guy here, because when we're looking at the right triangle, we want to identify which side we know, leg or hypotenuse. So this is a leg. The other leg will be the same. Hypotenuse will be root 2 times as much. On this one, I know a leg, so the other leg will be the same. And when I go from leg to hypotenuse, I'm putting a root 2, but really the mathy thing is times them by root 2. And since the 2 and the 3 are both in the roots, those are the numbers we want to multiply, so 2 root 6. Down here, I have the hypotenuse, and so when I go back, I need to take a root 2 off, or really divide by root 2, or really like take half and put a root 2, so 2 root 2 on both those legs. And then last but not least on this one here, I have the hypotenuse is 10 root 2, so both sides are just 10. This guy's so much easier. On to the next. So on page 78 right here, we have our little pattern. If this is n, and this is n, this is n root 2. So if I'm going from leg to hypotenuse, I want to times by root 2, which really just feels like I'm putting a root 2. If I'm going from hypotenuse to leg, I'm dividing a root 2, which sometimes just feels like I'm taking a root 2 off, or sometimes feels like I'm taking half and putting a root 2. So if the root 2 is where it's supposed to be, you just do it. But if it's not, then it's a little bit trickier. So for example, on this one here, I have the 2 legs are 3. So the hypotenuse is 3 root 2. I have the 2 legs are 5.5. That's super gross. I'd leave it 11 over 2, but you know. It's 5.5 root 2. On this one here, I have the hypotenuse is 5. Like that's normally where the root 2 is supposed to be. But since it's not, these are going to definitely have root 2's on them. And then I need to take half, so 5 over 2, or 2.5. Here I have the hypotenuse. It's 3 root 2. That's where the root 2 is supposed to be. So these are both just 3. Alrighty, on this one here, we have our legs. So when we're going leg to hypotenuse, we need to times by root 2 or like put a root 2 on it. So I can multiply inside numbers and we'll have 5 root 10. Here I have the hypotenuse. So when I'm going hypotenuse to leg, mathy, what I'm doing is dividing by a root 2, or I'm taking half and putting a root 2. So if I take half and then put a root 2, it's root 6 because I have a 2 and a 3 under, and they're both the same. Okay. You might want to look at that mixed practice next that I already have done over here. Spoiler alert.